There are a lot of names for it. Stealth quadratics is one, or the more boring stuff is like more complex quadratic equations, or an equation that is quadratic in some function of x. And I think that probably the key example is like something when you get an x to the power of 4, something like this. If you think about it, it is somewhat in the form of ax squared plus bx plus c, because x squared is x to the power of 4, and then you've still got that constant on the end. So what you could say is let u equal x squared. This just helps you not make very much mistakes and prevents you from getting confused with the powers. And then you'd say u squared minus 13u plus 36 equals 0. And then you factorize. What's that? U minus 9, u minus 4 equals 0, because minus 9 plus minus 4 is minus 13, and minus 9 times minus 4 is 36. And then you'd go u equals 9 or u equals 4. And then you'd say, well, x squared equals 9 and x squared equals 4. So x equals 2 or x equals minus 2, and x equals 3 or x equals minus 3. And then also it could look like this. Now, because remember, this is x to the power of half, you could say let u equal root x, and then it'd be 2u squared minus 9u plus 10 equals 0. And then AC, that's 20. And then you do minus 4y minus 5, u plus 10 equals 0, 2u, u minus 2, minus 5, u minus 2, and then you just keep going. And then you'd have to square that, so then stuff like that. And you could have a whole raft of things, like it could be in the denominator, or not even to the power of 4, it could be to the power of 6 and to the power of 3, and all that. And so, yeah, these ones, they may look impossible, but if you break it down, it's a secret quadratic or a stealth quadratic, and you can solve it using those same skills. And usually in the exam, they factorize, which is very nice. So that's pretty much it for this video. In the next video, we will be looking at using the discriminant.